Hello, and welcome to FODES, the Future of Design and Engineering Software podcast. My name is Rupinder Tara. On this show, we will have guests that will discuss tools and technology that engineers will find interesting and useful. Today we have as our guest Antony Samuel. Antony is a co-founder and CEO of Artifact.Engineer. He is a degreed electrical engineer from Georgia Institute of Technology, and his company has been fortunate enough to have a good round of financing. Antony, can you tell me about how you got your financing?
When we were doing our fundraising round. That was back in March. So we had been in the Combinator Startup Accelerator out in San Francisco for 3 months. At the end of the Startup Accelerator, they do demo day as well as they open up the floors for a lot of these companies to do their fundraising round. We were lucky enough to have Floodgate and Boost VC be leading those rounds as well as a couple of other great investors. But yeah, raising our $3.5 million seed round really puts us in a good position to set up shop, hire some excellent engineering talent, and build a compelling design software that's helping electrical engineers build their systems.
So congratulations with that.
Thank you.
But it's a bit of a surprise because we met here in San Francisco during a session I was moderating, and you were on the panel. And we always think San Francisco is the center of the universe, but you're in New York.
Yeah,
Did that
correct. Yeah.
happen?
Yeah, my co-founder was actually already in New York, which is why we set up shop here. And I think there's a lot of really interesting hardware companies in San Francisco, in LA. But a lot of people forget that there's big hubs in New York, specifically Brooklyn, Boston, Denver, Austin, Texas, Atlanta as well. So lots of different cities here in the US all building pretty complex hardware. Definitely exciting though.
I concede that there are other places. New York always thinks of itself as the financial capital of the
Yeah.
world, and which bothers me. Many other things, publishing as well. It's like we always have this East Coast, West Coast rival. We didn't get a chance to explore in that
Mhm.
panel, which was all about AI for engineers and manufacturing. You didn't really get a chance to explore what Artifact does, and I was thought of you this morning because I read this news report about Siemens, and it was talking about what I thought Artifact did, make a system level design automation program. And I thought more of what we talked about in the panel which was, are you at all worried about these big guys coming in and eating your lunch? Right? Did that happen this morning?
Not too bad. And I'm gonna dig a little bit more into it. But yeah, no, I think it's an important question to be thinking about any kind of small entrant who's really trying to play that innovator's dilemma game
Yeah.
against an incumbent. You really have to think about, okay, what value is that small team going to provide? And what is like the rate of development that a small team can provide compared to one of these incumbents? So yeah, I mean, I'm super excited about what Siemens is working on. It's something where the tide raises all boats. How I think the mindset around big complex systems engineering, specifically with electrical, we really want to provide a lot more systems awareness to every individual engineer. When I hear that Siemens is working on that, in my head, it's like, all right, one of the biggest players in the space is validating that this is a meaningful market and the right direction for engineering to go. Now, on the flip side, am I excited about competing with Siemens from a usability and UI perspective, something that has kind of like thinking about the AI hooks at its core of an application? Yeah, it seems like an exciting problem. It's a compelling problem. I've been a Siemens user before in the past for designing aircraft, supersonic jets. I'm very familiar with their stack. It's going to be a fun challenge thinking about how Artifact thinks about the problem a little bit differently.
Startups are definitely more nimble than this multi-billion-dollar manufacturing conglomerate, that's for
Oh yeah.
sure. You mentioned you worked for Supersonic Flight. It was Boom. You worked for Boom, and
And Hermias,
wow,
yeah.
it's getting quite a bit of attention in this world. And it exemplifies what you're talking about, that even small companies, agile companies can compete with giants because here they are competing with Lockheed and Boeing
Yep,
and
you got it.
aircraft companies, right?
I like to think that Boom and Hermias, they were doing it before it was cool. They're the underdogs kind of fighting. Like for Boom, it was like Boeing, and then for Hermias, certainly more of the defense primes. And I think that they were very convicted that the right way to build this was from a small team, moving very quickly, iterating fast. I think SpaceX probably maybe trailblazed a lot of the culture around this is actually possible. We can't just let the legacy primes figure it out on their own. Of course, like working very closely with the legacy primes is important for success, especially from a national defense standpoint. I certainly don't over-index on it's not startups versus the big companies. It is like, hey, how do we solve this engineering problem kind of alongside each other because we're all chasing the same vision. Working at Boom, at Hermias, I think getting those contextualized repetitions, getting that practice, everything from building teams to iterating through development cycles. Super, super blessed and glad that I had those experiences. It certainly shapes how we build our product as well.
Yeah, yeah. It's not just aircraft, it's industry wide now. The idea
Right.
that can a room full of engineers actually design a supersonic aircraft? Can a small team actually make a new car? I was very disappointed that Apple dropped its plans for the iCar.
Oh yeah.
I was sure they were going to design a better car than anybody else. I love the way that software and now AI is giving engineers a way to fly high with design. I've been very critical over the last couple of years since ChatGPT came out, how design companies were disregarding AI because they thought, oh, and what can they do for us? Nothing. And they dragged their feet on implementing AI. I was very encouraged to see companies like Artifact and others, the others on our panels too, finally presenting applications that use AI for engineering purpose. It's quite gratifying.
Yeah, absolutely. I think we certainly saw the software world be the first wave of folks who are adopting these new tools and really rethinking, hey, what's it going to take for us to be able to leverage this new technical capability? I think we're seeing in the hardware world it lagging behind, but certainly that's where Artifact is trying to ride that curve before it really starts ramping up. Cultural perspective, a lot of the hardware engineers, maybe they don't want to trust the like the AI black box, the magic thing, because the inputs have to be perfect and the outputs have to be very verifiable. So it is important as we are building these, whether it's Artifact, whether it's other companies, for these highly critical systems, for these highly complex systems, really kind of having a certain level of reverence for what the AI is actually doing to help these engineers, but also allowing engineers to be very technically competent, be held to a very high level of accountability, because we certainly don't want to AI magic away responsibility, especially when you have these highly critical systems. There's maybe anchoring it in, okay, how do we actually take what engineers are working on and really augment their capability and really reduce their iteration cycle speeds too? Thinking through those fun problems as well.
You touched on this as a very important subject for engineers, especially older ones, older, let's say established engineers who are kind of any
Yep.
new technology, right? Because they build planes that don't fall out of the sky for the most part, right? And they're very happy with that. They don't want to change anything. They don't want to optimize even. They want aircraft to be reliable, right? They're afraid. And here we are with this. Okay, now suddenly the doors open for considering all sorts of different things. There's always this problem I have with validation. Like none of these new designs are getting validated properly. Right? Maybe they are. But tell me, is this a problem that you consider validation?
Yeah, absolutely. I mean, I think you really want to think about like what are the core problems, like
Uh,
even independent of the technology, right? So let's say that we have in one hand our technology, which might be these AI tools, like for example, LLMs, but then very independent of how you implement it, we still have the technical problem of, hey, complex hardware is attempted to be built by everyone from small teams to large teams. And of course, there's the how do we actually design this in an efficient way? How do we verify and validate that the system is built right? How do we test these things right? And then how do we also support these when they're in their sustainment programs as well? And I think that there's, of course, the actual like technical axis of like, hey, how are we actually going to like think about the physics? But then there's also like a time and value in dollars axis as well, right? So I think it really is probably going to be good for everyone if more complex systems can be built faster and more reliably, right? Okay, so let's take that requirement for what it is. And then you're saying, okay, how do we do this? And then sometimes, whether it's computational fluid dynamics, or maybe it's Excel, or maybe it's the internet, or maybe now in the age of AI, it might be AI, you end up kind of starting with the question of, hey, how do we actually do engineering right? How do we actually like increase the capability of these companies that are chasing these ambitious projects? And then, hey, okay, we might have a technical unlock or a technology unlock that can actually allow us to do this, then great. That's something that's probably worth pursuing. Now, I certainly don't want to always just be like, hey, we're going to wave some AI magic at a problem and make it better. Something we like to do is go through the mental exercise of be very, very rigorous in terms of how are we defining the problem? What are the assumptions we're making? And then how are we going to attempt to solve it? And I think the same thing probably goes for the industry as well. It's not just like engineering with AI magic. It is how do you be very, very specific about the engineering problems that you have and how you're going to solve it. So take the planes falling out of the sky example you mentioned, maybe a little tongue in cheek. take, but even thinking about some of the famous vehicle programs for electrical systems, where has that actually held up vehicle programs, hundreds of millions or billions of dollars in just integration timelines, right? You can take like Airbus A380 is maybe the most famous example, but there are plenty. Everyone from the Global Hawk program to Air Force One, lots of downtime because of either electrical design mismatches, teams aren't collaborating with each other. You're installing these harnesses into a vehicle and they end up not being correct because maybe like teams weren't coordinating properly, manufacturing bill of materials being incorrect. So it ends up being the common source of failure for these big electrical systems. And then you're saying, okay, now I have a problem here. How do I actually make that better? And then you start considering AI as a potential aid to solving that problem. And then you build a product around that. And I think that that's maybe the order of operations that I find a little bit more compelling than just seeing what the AI spits out. That doesn't seem as rigorous.
Right, right. I think it definitely helps that you were in the industry and what engineers need to do in the industry, and you can adapt AI to that purpose, which is much more desirable than, say, somebody who's just a programmer, developer, and who says, "Hey, I can jump on this AI wave and make some money."
It definitely takes that the software engineer whiz or whizzes to also build it and bring a lot of the cool best practices in the software world to this hardware solution. So it's good to learn from those guys as well.
So you had I'd say, a pretty good career going. You worked at Boom, you worked at Hermes. You could have stayed in that business. Tell me about that light bulb that went off that said, "Hey, I've got to start Artifact."
Yeah, I certainly have much love for the team at Boom and at Hermes. That's something I certainly would have been very happy continuing. Certainly working with my co-founder, even just we had done like hackathon together just for fun. It'll be fun to catch up. We'll do something. It was hosted by the Ukrainian Minister of Defense. So we were out there working on can we come up with cool algorithms to potentially triangulate drones based off of their audio signatures. We ended up using our laptop microphones and putting them in positions that you can previously define, actually triangulate a source of a drone noise coming in. We were doing a demo where we had like a speaker making drone sounds and kind of walking around with it and seeing how these laptop microphones, based off of some actually surprisingly simple geometry, could actually triangulate where the drone was based off of how loud the drone sound was on different laptops.
What the Ukraine is doing with drones is incredible.
It's technically very intense, but we caught up over this and we were driving from LA to San Francisco for the hackathon. We're just talking about like some of the biggest problems that we see in the industry. At this point, Corbin, he had been exploring some AI tools for aerospace development, like when you're actually doing vehicle design. Hey, is there a way that we can think about vehicle configuration in a way that AI can help? I had recently onboarded one of our competitors' products at Hermes. I felt very convicted that this is actually a very meaningful space. It's not just the electrical design in a silo, but it's like, how do you actually think about the entire systems engineering problem for these planes or satellites or nuclear reactors or energy storage or whatever your problem might be? So I think that that was a way to just think about this is not only something that I'm personally feeling the pain of, but it started to become something that I believed that we could fix as well. So yeah, I think the more exciting part of the job these days is getting to really see a cross section of how electrical engineers and systems engineers build their product, industry agnostic, but also scale agnostic too. What are the big companies doing, like the DoD primes? What are the startups that are still two or three people in a basement doing? I think that making the jump from leading teams and being an individual contributor on the electrical engineering front to, hey, how do I actually think electrical engineering, maybe almost philosophically, should be done? That's been a very rewarding shift in the career. But, I
Right.
certainly have much love for the wrench turning PCB designing. That is, I'm sure you can relate to that as well.
How far ahead of you were you to where there were funds available? Because you must have had this idea before venture capitalists even knew how to spell CAD.
It all went actually a lot faster than I had anticipated. We had, on a whim, applied to Y Combinator, the startup accelerator out in San Francisco, and they just said, all right, like we had nothing but an idea and maybe like 2 slides. Hey, this is what we're going to be building. And I guess, I don't know, maybe it's something about me and Corbin having come from the engineering space and maybe like the passion and conviction that we had around the problem came through. Starting with that, they took a bet on us, which I'm very grateful for. And then going through that Y Combinator program, taking about 9 weeks to really build out, hey, what does a roadmap actually look like? What does a minimum viable product look like? And then having a couple customers who are willing to take a bet on us and get in contract and be design partners with us as we were going to build out this pretty difficult, pretty intense CAD tool. And I think having those early believers who understood the problem and understood what we were going to do, that allowed us to actually do some fundraising in March. Hey, like, okay, you have some customers who are actually like have validated that this problem is real. And the investors, for the most part, were pretty excited to say, all right, we'll take a small bet here and then build it out, actually get it in use, learn from it, make it better. And then I guess the future fundraising rounds, we'll see what happens there.
What did mom and dad say when you said, I want to do a startup?
You
Yeah,
know, no, I'm lucky that they've always been pretty supportive. I remember, I think I was like graduating college and I wanted to work at a startup. I'd been in a couple different aerospace startups. So maybe a lot of folks didn't know what startups were. So they certainly had their questions. I think really throughout my entire career, they've been very supportive of chasing what the most interesting problem to Antony is. So I very much appreciate their support. I certainly wouldn't have been able to do it without them either.
tell me more about your upbringing. You're Indian, right? Your
Yeah,
parents, they live
yeah,
in
both my
India?
parents. No, they're actually in Houston. But
Okay.
yeah, older sister, younger brother came to the U.S. before I was born. I
Mhm.
was born in Texas, lived overseas for a couple years because my dad worked in oil and gas. Then went back to Texas for middle school and high school. Went to Georgia Tech in Atlanta, which is a phenomenal school. And then yeah, was lucky enough to do some internships at some aerospace companies. There's one in Atlanta called Generation Orbit, which is actually my first aerospace startup. And yeah, it was a phenomenal, phenomenal team. So I was very lucky. I was laying harnesses, I was bending tubes, we were lighting rocket engines. And this team, the leadership team at Generation Orbit, ended up actually being the founding team at Hermeus, which is how I had that connection. Dipping my toes in that aerospace world, I realized, hey, it's just certainly more exciting for me to be a part of this small team chasing a big problem, maybe opposed to working at one of the Boeings or one of the bigger companies. I felt like it was personally very exciting to me to work at a startup, which is kind of ended up going down that route.
The only professions permitted in my family were I was going to be a doctor or I was
Yeah,
going to be
yeah.
an engineer. So, right. So I chose engineering, which I didn't realize was the harder of the two.
You
I've
chose
heard this
wrong.
from people who have both. There's a very small intersection of doctors and engineers, but they have said without exception that engineering was a harder one, right? This was a
Oh,
harder
yeah.
one.
Yeah, we have a family of engineers too. My older sister, she was an industrial engineer and then spent the last 10, almost 11 years now in finance. Then my younger brother, he did computer science. He's in Dallas actually working at Lockheed Martin. But
So he's the
yeah.
black sheep then.
Oh, I wouldn't say that. I would say maybe, yeah, they're both much smarter than I am. Maybe, no, no, but no, my parents did a good job there for certain.
Yes, they did. I'd say they're three for three. That's great. What does Artifact? We didn't get into this. What does Artifact do actually?
Yeah.
Tell me the problem it solves.
Perfect. So Artifact is a system design tool for the electrical systems. So when you open up the hood of your car, you can see all of these wires going from all of these electrical boxes, given power, given data, whatever it might be. And we're helping the engineers actually design that nervous system, all the wires that they might see, whether it's a car, whether it's a rocket, a plane, a nuclear reactor, really any big piece of hardware that's typically very multidisciplinary, lots of interdependencies between their systems. We help them design their big system as a whole. And the output is these drawings of the wires and the cables and the harnesses that they typically see.
Yeah. Okay.
So this is not at the chip level, and it's also not at the circuit board level. It's actually one level above that. When folks have a bunch of circuit boards or they have a bunch of electrical boxes, that's where we come in. We help them actually design out these system schematics and then be able to export out the manufacturing drawings for the harnesses themselves.
Okay. Is there any optimization going on at this point that AI could be helping with?
Yeah, so there is a bit of an order of operations here.
Okay.
I think that where we spend a lot of time thinking about is how do we, our atomic units, right, our elementary operations, the tools that currently exist in the space often are pretty limited. They're pretty clunky. The UIs aren't great. So we're actually spending a lot of our time, especially in our first year of, hey, let's build out our initial product, is actually getting those non-AI features done right first. You can think about it as like building VS Code before you go out and build Cursor. So we actually spend a lot of time just thinking about how do we actually be very, very flexible to lots of different types of electrical systems. The same way that 3D CAD is very generic. It's not you typically don't have CAD that's hyper optimized for aerospace or automotive or anything. It's kind of CAD is CAD. So we're trying to really figure out and kind of invent often what does that look like for electrical systems, both at the design side, but also on the collaboration side. Like what's the right way to have teams of tens or hundreds or thousands of engineers actually designing their systems in concurrence, both at the component level, but how do you actually design a system or a system of systems? How do they interact with each other? We're actually building out a lot of those. Optimization, as you mentioned, that becomes the layer that we build throughout as well as on top these elementary operations and these atomic units that I mentioned.
Right. At what stage would a EE electrical engineer use your application? Would it be at the concept level? And then also, does it interface with the standard EDA packages like Siemens or Mentor, Synopsys, any of
Yeah,
the?
the vision for the product is to really go the entire product lifecycle. So we want to start at conceptual design, go to detailed design, go into the manufacturing, the vendor management, all the way to integration and test, and then sustainment. Right now, we're really focused on that detailed design to manufacturing and procurement step in the process. But I really see conceptual design to detailed design being a big, big opportunity for the AI to actually propagate out. I have this block diagram and I have this parts library, like go out and make some of these drawings for me. That certainly seems pretty inevitable, and we're building a lot of those hooks into our application today. Right now, we got to make sure that the detailed design canvas is actually done right so we can have all the right data types for people to load in their conceptual designs and create the detailed designs that they'll have. The integrations are certainly going to be a long-term requirement. In the short term, it actually doesn't seem like an initial requirement for a lot of our mid-market and startup customers. But yeah, eventually being able to hook into Altium and KiCad on the PCB side, into SolidWorks and NX and Onshape. We really want to be seamless with the entire workflow, especially having a single source of truth for the electrical design. That also includes really the whole system. So we see an opportunity to actually link into everything, hopefully maintain that single source of truth as well.
Are you a product to show yet, or is that to be the future?
Sure. Yeah, happy to
Okay.
show it. Can you see my screen all right?
Yes.
Perfect. So yeah, this is typically what people see when they log into Artifact. They see this big canvas, they can navigate through the projects in their system, or they can open up a drawing that's previously existing. Everything we have is version controlled and tagged. You can branch off of things, you can create your read-only drawings, all that good stuff. This is typically the first drawing that I'll put in front of a customer. This is a very, very simple fake drawing. No electrical system would ever be this simple, but it shows off a lot of the capabilities that people can typically expect out of a tool like Artifact. Having things like hey, I'm going to have my single board computer here. I'm going to go out to some type of motor controller, which goes out to some set of connections, going out to maybe some wings or a rudder, and then being able to do some pretty cool features like, okay, hey, like what if I wanted to trace my nets throughout my system? We have the Google Docs style real-time collaboration as well. So really, you can have anyone in your org pull up this diagram as well. But we really try to keep it very easy to create these types of systems. I'll typically do this example where I'm going to bring in a flight computer, I'm going to bring in a Ethernet cable, and then I'm going to just bring in a Ethernet jack. And if I just want to really quickly create these connections, have my function names cascade, and then once I've actually designed out a system like this using these pretty intuitive drag and drop features, how do I actually see like my full list of connections, every source, every target, and how they connect? I want to see a full bill of materials so my procurement team knows what are all the boxes I need, what are all the connections I need, how long of cable do I need to build this system, and what are the tools that I need to build the system. And then going out and being able to export these drawings to my team of technicians or whatever as well. We spent a lot of time thinking of what's the most intuitive way for engineers to go out and design their systems, but also like for these big teams, how do we make sure that everyone's looking at the same source of information and building the right thing as effectively as possible as well? But yeah, this is a very introductory version of the demo I'll do for customers.
Very interesting. It reminds me of, I don't know if you've heard of Visio. Visio
Yeah.
is a drag and drop application that you could just pick shapes, but yours seems to combine the two things, the drag and drop interface with the electrical intelligence.
I'm really glad you mentioned this. So typically how people are designing their systems is I've actually, people are always surprised when I tell them I've designed supersonic jets in Visio. But yeah, like one solution is you the PowerPoints and the draw.ios and the Visio. And then the other are the 40-year-old enterprise tools for electrical wire drawing. And we wanted to bring the smarts and the capability of these electrical system drawings, like the PCB tools. How do we actually bring a lot of that intelligence into the tool? From a customer UI perspective, how do we actually keep it very simple? Like almost we want to be deceptively intelligent for what the UI is. So we take a lot of the design cues from the Visios and the Dryos because they do a really excellent job of being very intuitive to a new user. So we certainly take a lot of those design elements from those worlds when we are building something with these extra layers of intelligence on top of it.
I'm surprised you knew about Visio just because Microsoft took that product and just about hit it in the portfolio, I think
Oh,
maybe
man.
30 years ago or so.
Very, very familiar with Visio. I've spent many, many hours, if not days or weeks, heads down in that tool.
For what it did, it was like perfect. It just lacked that engineering intelligence. Like shapes were just shapes. And I was very happy that they would be joined together That was
Mhm.
nice, but it didn't reflect flow diagrams. It didn't reflect flow. For electrical diagrams, it didn't reflect circuits. Something was missing. So it looks like you put that in.
There's the very bare bones, which is like how do you track your electrical nets? How do you have your function names propagate? All that
Mhm.
good stuff. But really, I think the layer on top of that is enabling technology. How do you actually get like an AI co-pilot that can help you design and help you
Right.
analyze and do these electrical rules checks and design rules checks?
The components you were picking were real life components. They were actually
Yep.
manufacturer's parts.
Correct. So
Yeah.
anything from circuit boards to electrical boxes,
Mhm.
connectors, cables, wires, we can specify those parts in a library and then drag those
Mhm.
in and then start connecting them that way too.
With each component, you're actually picking up the electrical characteristics of that.
So right now we have a very, very bare bones level of it. What are the pins? What are the connectors that are inside? What are the
Okay.
mating part numbers for
Okay.
wires? We take in wire gauge, and then really we want to build in a lot of those electrical smarts, everything from characteristic impedance or maximum currents. All
Right.
of these become really required if you are going to do a meaningful set of electrical rules checks, is understanding, hey, what is everything that is going on with this component? We had an early prototype for a data sheet parser. We ended up putting that on pause just because it maybe seemed a little bit more of a science fair kind of like razzle dazzle than something that was going to be immediately impactful to our customers. But we kind of are bullish on that type of technology, really unlocking what can you actually learn when you're designing the system, opposed to when you've built it and integrated it. And unfortunately, you fry a fuel valve or you burn a motor, which are all things that I've done before, expensive failures. Really, we want to make sure people can learn those a little bit ahead of time.
Yeah, yeah, this seems ideal for, I understand, an electrical designer. He said electrical harnesses, wire harnesses, were like his whole job. That's all he did was make
Yep.
harnesses. And a car, like a Tesla, for example, could have many, many electrical harnesses and very complex too. Since the whole car's electrical system. That was a whole job for a whole department.
It is like a death by a thousand paper cuts type of challenge as well. Like any
Uh,
one wire is easy. When you have 10,000 wires, now it became hard, right? So the
yeah.
pain's the aggregate. So it is like a tricky type of technical problem.
So car would be one level, and I imagine like a fly-by-wire aircraft would be next order.
Oh yeah, definitely. Lots of the drone companies and the jet companies who are using Artifact, like the stakes are pretty high just because the sheer quantity of wires that they have. But going back to the idea of highly complex but also highly critical, if one of these wires is actually wrong, does that actually, mean your plane falls out of the sky or not? I guess it depends on the system,
Yeah.
but the criticality is pretty high for a lot of our customers.
So now you got your financing, so I imagine you're going to have to do some serious R&D before you go to the next level of funding, right? So what's
Yeah.
what's on the agenda? You mentioned that the system could be smarter, for example, it could know
Sure.
more about electrical performance. What else? Growing the team?
But I categorize these things into technical risks or technical de-risks, I should say, and then market de-risks as well.
Yeah.
So on the technical de-risk side, it's like, how do we actually build out something that is good, that it works, the real-time collaboration is good, the electrical smarts are good. Something quite like this doesn't really exist. We certainly have our very large share of technical things to figure out and implement in a smart way. Hiring exceptional software engineers comes into play. We've done that a little bit. We've hired our first employee from Tesla, incredible software engineer. So really making sure that we're holding that high bar for development. And then of course we also have the other side. This is like how do you actually de-risk the market? And this is where we're actually working with really ambitious startups, working with really ambitious mid-market customers, and also like working with these bigger companies too. Really making sure, hey, we understand their problems. We actually have like a go-to-market strategy. We want to build it, bring in their entire libraries. We want to bring in all of their pre-existing drawings and really actually do that in a meaningful way. And then validate our hypothesis. If we build this product that solves these problems, engineering teams can actually design their systems a lot more accurately and a lot faster, fewer integration challenges, and really making sure that the market validates that hypothesis. And that really just comes down to who are these early users going to be. We're a little bit after the design partnership phase. People are actually using our tool, which is exciting to see, but being very, very responsive to our customers, figuring out what are the next problems they have, and then how do we keep on growing the tool that keeps up with pace of what our customers need as well.
I'm looking at your LinkedIn profile and I'm looking for a business degree because you sound like you have one, but
Very far
where,
from it.
where did you pick up this business knowledge then?
It's hard to pinpoint it exactly. I think probably a combination of having worked at a couple different startups, whether it was the founders at Boom, the founders at Hermeus and Generation Orbit, the same crew. But I'm very lucky to have those technical mentors professionally. Of course, the friends, the family who have also been great at sharing advice. Learning from all these people around me has certainly been very important for me not floundering too much. I'm an electrical engineer. I'm a circuit circuit boards guy. So going into YC, it was certainly a little bit of a different space. I'm not an investor. I'm not in the VC world. I don't know the famous names. I don't know the magic words to say when you're raising money. But I think just being able to learn from all the people around you and being truly excited about the problem that you're trying to solve, that combo kind of worked out for us, or so far it has. Continuing to learn from a lot of the people around me is the name of the game for us.
I'm very glad to see you have the measure of success you've had already, and I hope to hear of greater things in the future. I'm very encouraged that engineers are being recognized for what they can do, and it's not just startup people with good ideas only. It's like real engineers trying to fix problems. So I wish you the best of luck, and I hope for greater things. I hope to stay in touch.
Absolutely. It was great getting to chat with you today. Hope you have a great
Yeah.
rest of your day.
Thanks very much, Antony. Thanks for your
All right.
time. Thank you for listening to FODES, the Future of Design and Engineering Software show, brought to you by Eng Technica. I hope you have learned of a new application or technology that will help you with your job. If you have an application you think would be of interest to other engineers, please let me know by emailing me at rupinder@engtechnica.com or message me on LinkedIn.